Okay, today's lesson is lesson number 52. We're talking about domain, range, and other characteristics of graphs. Here are the first four definitions that we're going to use in this lesson. The first is domain, which is the set of all possible x values that can be used as inputs for a function. So on this image over here, the domain is this set of x values, right? So all of these x values have a y value that corresponds to them, so they can all be used as inputs for this particular function. The range is the set of output values of a function, which we would say are the y values, right? So the y values for this function go from this point to this point. So these are all appropriate y values. Those are values that we would get as outputs when we plug in values from the domain. Okay. The maximum, or we can just say the max, is the largest output or y value. So the max of this function occurs at this point, so the corresponding y value would be the max. So for this graph it happens, let's say about y equals 3.2, somewhere around there is the max. Then the minimum, or we can just say the min, is the smallest output or the smallest y value. And here it looks like that occurs at this point, which is when y equals 1. Okay? So for something simple like a line, our domain, which remember is the set of x values, so we're looking here, our domain for a line, we never really have a problem. We can always plug in different x values. So our domain, we say, is all real x, or we can write that in interval notation as the set from negative infinity to infinity. Okay, and then similarly the range, which is our y values, I will eventually get all different y values for this function, so I would say, again, my range is all real y, or I can write that as the interval from negative infinity to infinity. My max for this line, the maximum, doesn't really exist because I can always go further up. So there really is no highest point. So I would say none. And then similarly, the minimum, I can always go down. So there's no lowest point either. So I would say none. This next graph is a little more interesting. You'll see it doesn't have arrows on the ends. It has an open circle and a closed circle. So that tells us that this graph doesn't exist at this point. Okay, so I can't plug in negative 5 to this function. I wouldn't get anything out. I would get no solution. But I could plug in negative 4.999 and get really, really close to this circle, but I wouldn't be directly on it. So at negative 5, I have an issue. Then positive 5, the closed circle, just means I can go all the way up to 5 and I can include it. Okay, so for our domain, as we're going from left to right on our x, I see that the function starts here and stops here. So I would write my domain as the interval from negative 5 to 5. And I have open parentheses on this side because of that open circle, right? I can't include that point. And then I would use a closed parenthesis at the 5 because that point is included. Okay, then for the range, I'm looking at the y. What happens is I go from the bottom to the top. I see that I run into the function here. It starts at this point. And then I keep going, and it looks like it stops at this point. So for my range, I'm going to go from negative 4 up to 3. At negative 4, I'm where this open circle happens, so I can't include that point. I'm going to use an open parenthesis. And then at positive 3, it's just a point on the function, so I can include that point, and I'll use a close parenthesis or a bracket on the right side. Okay, so then looking at the range, I can figure out what's my maximum and what's my minimum. So max is going to be my highest y value, and that will happen right here, right? This point that we were looking at. So for my max, I would say that y equals 3. And then the min is the lowest point of the function, which happens here. So for the minimum, I would say y equals negative 4. Okay, so this example is pretty similar. I'm not going to go through it again on here, but it should be in your notes. Here are a couple more definitions. This is increasing, and this is for decreasing intervals. The important part to realize is this last part. So for increasing, I need to know that as x is getting bigger, y is also getting bigger. So as I walk from left to right on my function, my y values are getting bigger. So it's like I'm walking uphill. Okay, it's like a positive slope if we were just dealing with a line. And then decreasing is what happens when x is getting bigger but y is getting smaller. So again, I'm still walking from left to right along my x, but if my y values are going down, then I'm kind of going downhill. So we would say the function is decreasing there. Okay, so again, back to our example with the line. If I was walking across this graph from left to right, I would be kind of standing here, right, and I'm going uphill. So the function is increasing then. And there's never any point where it turns and goes downhill because it's just a line, so it is increasing for the entire function. So I would say it's increasing on the interval from negative infinity to infinity, or I could say increasing for all x. Okay, this interval is talking about my x values. Okay, so if I wanted to write it in with inequalities, I would say negative infinity is less than x is less than infinity. And back to this second graph, if I start here, I'm going from left to right, and I want to see what's happening at each interval. Am I increasing or decreasing? So this first piece looks like I would be going uphill. So I would say that the function is increasing from negative 5 all the way up these x values until negative 2, right? That's where I stop going uphill. I'm using open parentheses on either end of this because I can't really include, first of all, this is an open circle, so that's already not included. But this point here at negative 2, I'm not exactly going uphill anymore. It's sort of a transitional step, so I'm going uphill, uphill, uphill all in here, and then when I get to negative 2, I'm stopped, and I'm about to turn and go downhill, right? So let's look at the next section. For the whole rest of this graph, I'm actually going downhill, right? There's kind of a curvy part and then a straight part, but both of them are downhill. So I would say my function is decreasing on the interval from negative 2 to 5. Again, I get that by looking at the x values that correspond to the downhill section. Okay? And just one more time, I could also write these with inequalities, and I would say negative 5 is less than x is less than negative 2 is where the function is increasing, then negative 2 is less than x is less than 5 is where the function is decreasing. Okay, and I'm going to skip that example. Okay, so now we're looking at all these things being put together with one graph. So this is the graph of what's called an exponential, but that's not really important to know because all we really want to do now is just look at a picture of a graph and determine these things from it. Okay, so let's talk about the domain and range first. Remember that my domain is talking about x and the range is talking about y. So my domain, I see that I have arrows on either end here. So it's going on forever in both directions. So I can write my domain as the interval from negative infinity to infinity. Again, or this, I could say this is all real x. For my range, it's definitely going up forever, I can tell, right? But at the lower end, I want to see is where I stop, or if I do. So looking over here, I see the graph sort of flattens out, right? It becomes nearly horizontal. So what's happening in my range is that the y values are only going to go from negative 1 to infinity. So the lowest they go is this point right here at negative 1, and then they go up forever. Which means that my max then doesn't exist because it keeps going up forever, right? And my minimum happens at y equals negative 1. So then I'm looking if this function is increasing or decreasing. I think, okay, if I stand over here on the very left and I start to walk to the right, am I going uphill or downhill? And even though it's almost horizontal, there is a little bit of a slope on this part of the graph. So I am actually going uphill the whole time. Once I get here, it becomes a lot steeper of a hill, but it's still uphill nonetheless. So I would say I'm increasing from negative infinity to infinity, which is our entire domain. So I'm not decreasing at all. This last part says, as x goes to infinity, ... So you're finishing this statement. So what's happening as x goes to infinity, or as x gets really, really big? So I'm thinking as I go out on the x-axis, say I plug in 100, what happens to y? Is y going to kind of level out and be something like 6.1, or does it go down dramatically? And of course for this function it does neither of those things, it goes up forever. So as x goes to infinity, we would say y goes to infinity as well. Okay. If you want to write that in symbols, you could write y with an arrow. So this is y goes to, and then an infinity symbol. Okay. This next example we just touched on in the first class, and I know the second class didn't get a chance to talk about it, so I'm going to spend a few minutes on this one. Again, the domain is talking about your x, and your range is talking about y. So domain on this function, I see that this arrow is going on forever and this arrow is going on forever, which means I'm not going to have any problems with x. I can always plug in any x value. So my domain goes from negative infinity to infinity. My range, though, if I'm looking, what happens as I go from the bottom to the top? Down here, it doesn't look like I have any function values. So I need to look at where my function starts, which it looks like is this point right here. And then it goes up and on for up to infinity. So my range, I can write as the interval from from 1 to infinity. Because those are all possible outputs for this function. Since this goes off to infinity, that means that my max doesn't exist, so I could write none. And my minimum occurs at this point, so that is when y is equal to 1. Now, if I look at this graph, I can see that if I start on this side, I'm walking to the left. I'm starting at the left, walking to the right. I'm walking downhill at first, right? So for the first interval, when I'm coming from negative infinity and I'm walking to the right, I'm going to be decreasing, so this needs to go here. I'm going to be decreasing from negative infinity until I stop going downhill, right, which happens here. This is when I turn, I make a sharp turn and then go uphill. So that happens when x equals negative 2. So I would say the function is decreasing from negative infinity to negative 2. Then I turn around and start going uphill, so I'm increasing from negative 2 until I finish, right? I'm on forever until infinity. So then I can see, okay, so what's happening in general as x gets really, really big? As x goes to infinity, it looks like this is just continuing to go up, so I would say that y goes to infinity on this for this function as well. This is an interesting example, and I hope that you guys are taking the time to look at this one because there's a similar one on your homework. For this, it's a straight line, which we saw before, but that one had a slope. So this is a vertical line. So when I look at domain and range, the only x value that I have is 3, right? I don't have anything going on over here or over here. Okay, I only have something going on when x equals 3. So for my domain, I would just say x equals 3. My range, though, for my y values, as I go up, I don't have any problems, right? There's always an output. So for my range, I would say negative infinity to infinity. And then since that's my range, that means I have no maximum and there is no minimum, right? Because I can always go bigger and I can always go smaller. There's no highest point and there's no lowest point. Then I have increasing and decreasing. So if I'm standing on this, I can't really walk to the right, right? I can only walk up. So I actually am not increasing or decreasing, right? If we looked at this as the equation of a line, which would just be x equals 3, I have no slope, right? So the slope would be undefined. So I'm not increasing and I'm not decreasing. Then for the last part, as x goes to infinity, it doesn't really apply in this case because x doesn't go to infinity. X only goes to 3 and it stops there. Okay, so we would just leave those ones blank. Okay, and I know this is getting a little long, but I'll just include one more example if you guys are looking for help on your homework. So this is an example of a parabola. There's actually arrows on here, it just got cut off. So for my domain, I'm looking at x values, and since there's arrows, this goes on and on forever, so my domain is all real x, or I can write negative infinity to infinity. My range for y values, my function goes on forever in the negative direction, but as I'm going up, I realize that it stops here. I don't have any values above. So my range is the interval from negative infinity to this point, which is 4. Then I have a maximum at y equals 4, and because it goes on forever in the negative direction, I would say I have no minimum. So there's none. If I start on the far left and go to walk right, I'm going uphill. So I'm increasing from negative infinity until I stop going uphill, which happens here, right? I'm at the top of the hill, and then I'm about to go down. So I'm going uphill until x equals 0. So I would say my interval is, or my function is increasing from negative infinity to 0. Then after 0, I go downhill forever, so it's decreasing from 0 to infinity. As x goes to infinity, as I get bigger and bigger with my x, I notice that the y values are going down, and they're going to continue to go down, so I would say y goes to negative infinity here. Alright, and that's all for this lesson. Good luck on your homework. If you have any questions, you can always come in and ask for help. Thank you.